Assalamu alaikum. Dear students, welcome to Sensor and Actuator course. My name is Yousef Al-Shaili, and today I'm going to discuss with you how to control a stepper motor using MATLAB Simulink and data acquisition. It's going to be very interesting. So relax and try to enjoy the lab. In order to perform this experiment, we need desktop PC with a Simulink, MATLAB Simulink software. And inside this Simulink software, we need the toolbox, special toolbox in Simulink called Real-Time Windows Target. This toolbox, you will not have it in your laptop. You can have the software for MATLAB Simulink, but not this toolbox, the Real-Time Windows Target. This toolbox, we need it in order to connect this data acquisition. Data acquisition, we're going to use it to connect the digital system to analog system, which is our stepper motor. And it is from Humosoft. Its model is 624 BCI data acquisition. BCI, this is the BCI connection here, which is connected inside the computer. It's not a USB connection. It is BCI connection. So we are going to use what we called analog output inside this data acquisition, which is connecting, is receiving data from a digital system, from the computer as an input, and then convert it to analog data. So from digital to analog converter is called it analog output. Okay, we'll see how to use this data acquisition, and also we have a stepper motor mini type, small type. Stepper motor, it has 4 coils, input A, B, C, and D, and it needs a VCC equal to 12 volt and ground from data acquisition. We don't need any extra source. We're going to give it a source from data acquisition because it is a mini type stepper motor. It doesn't need any high torque. And the drivers, as you can see, are transistors. For each coil, we have one transistor BC337, and this is the stepper motor. Okay, let's see how we can use the stepper motor and how we can use MATLAB to control it. The objective of this experiment is to perform these parts, these test for the stepper motor. Initially, we start with single coil control, single coil, so activating one coil at a time. Coil A, then coil B, then coil C, then coil D, and so on. And second one is full step control in clockwise direction. Third one is a full step again, but with high speed, controlling the speed of stepper motor. And the fourth one is counterclockwise, how to control the direction of the stepper motor. And finally is a half step control. We'll explain the full step and half step when we come to that part. Okay, let's start with initially single coil control. So let's set up the MATLAB. Initially, let's go and open Simulink library. And in Simulink library, we have all these toolbox for seeing in Simulink. Let's open a new file where we're gonna build our circuit. The special toolbox we talked about is called Real-Time Windows Target. This is where we can use our data acquisition. So if we press this one, Real-Time Windows Target, we can have all these components inside. What we need is to convert digital to analog. So we need analog output. Analog output will convert the digital data to analog data. So digital to analog converter. We also need source to control the pulses, to control the coils. So we need pulse generator from source, from Simulink toolbox, pulse generator. We're going to send pulses to activate the coil, and we need to see these pulses. So we need from sync, we need one scope to see those pulses. Those all what we need as a components. Let's see how we connect those in order to control the stepper mode. Okay, for analog output, we need initially to set up the board. If it is not installed, we install a new one. If it is installed, we just choose it. Our board is MF624. Sample time, we set it to 0.01. We need it to be fast. Maximum, well, let's just put it at 10. This is output channel, channel number 1. We're gonna need 4 channels. Initial and final value, just put it 0, 0. Now this is for to activate one coil. This one, we need 4 of them for 4 coils. And we need to change the output channel. So channel 1 and then channel 2. This is channel 2. The other data are all the same. And then channel 3 and channel 4. So 4 channels to activate 4 coils. Let's put them in a better way. Let's create a subsystem. Create subsystem. Okay. And instead of input 1, let's put them just like the coil, input A, input B, input C, and input D. Just what we have in the stepper motor board. Okay. And we can call this one, let's call it motor driver, because it's going to drive the coil. This is this signal that is driving the coil, so we call it motor driver. Okay, it's done for this. Now let's see the pulse generator. We're gonna need also 4 pulses. Let's see how to set the pulse generator. So the voltage, the amplitude, we need 5 volts. The period, since we have 4 coils, let's run it for 4 seconds. So 1 second for a coil. Since 1 second, we need a percentage of that one is 25%, which means that 1 second per coil. Now the phase delay for the first one will start from 0. Let's say it's from 0, activating coil A, and then that will be for 25%. That is for 1 second. So coil A will be activated for 1 second, starting from 0, and then it will be 0 for the rest of 3 seconds. And then second number 2 will activate coil number 2. And second number 3 will activate coil number 3. Second number 4 will activate coil number 4. And then we repeat coil 1, 2, 3, 4, and so on. Okay. Let's see how to do the rest. So for the rest, also we need 4 pulses. So let's take 4 pulse generator for activating 4 coils. And all what we need to change, the same setting, all what we need to change is where to start it. So let's delay the second one for 1 second, delay the third one for 2 seconds, that is started after 2 seconds, and delay the third one for 3 seconds. So first one will start from 1 second, then the second number 2 start another one up to 4 seconds. Let's create a subsystem so that we put them in a better way. And we can call this pulse generator. Okay. So now you understand how we set the pulse generator and how we set the driver for the motor. Let's connect the scope so we can see the 4 channels. Now we connect them together. We need 4 channels, so double click on the scope and change the setting number of axes to 4 instead of 1. And let's change the style as well. Instead of black color, let's use white color and black drawing. So let's play with the color and with the line width as well. So we have 4 channels, as you can see now in the scope, 4 channels where we can see the 4 pulses. Okay. Now let's connect the scope. Let's rotate it first so we can connect it easily. Okay. Channel 1, channel 2, channel 3, and channel 4. I'm doing this one in steps, in details for you. But then bar 2 and 3, I'll just leave few procedure to do it yourself. So now it's connected. The pulse is connected to the motor. The scope is connected. Everything is ready. Let's see how to set the simulation to a real time. Now it is at normal. If you can see normal, is not connected yet to data acquisition or to external mode. So let's see how to set it to external mode. Okay. For setting it, we need to go to simulation. It is at normal mode. We need to change it to external. So we go to simulation, model configuration parameter. And from there, we don't need variable. We'll choose fixed step, fixed step. And instead of auto, we know that our sample time is 0.01. So we go to code generation and we change this GRT to real time. We're going to use real time Windows target. Of course, you don't have this one in your laptop, but don't worry, I'll give you another task to do. Let's press OK. Setup is done. Let's press OK. Now we need to, this is external now. Instead of 10 seconds, let's use 8 seconds because one cycle is 4 seconds. So choose it and let's do for 2 cycles. We need to build our system and then we can run it. Before running it, we need to build. So let's build it. And you can view the building. If there is any error or warning, it will give you the error. If not, it will give you successfully built. Okay, let's wait for a minute. You can see the process of building the model. Once it is done, if everything is fine, it will give you successfully. You can see there, successfully completion of build. So everything is fine. System, let's now start the system and see how it is functioning. Don't forget that this one, what we did here is what we call a single coil driving or activation is a single coil. So coil by coil. Okay, that is part 1. Okay, let's run the system and see how it is working. So let's have also the picture of the motor itself. We'll put a camera to see the motor, how it is driving. So we have the motor, we have the system, and we have the scope for pulses. We're going to activate one coil at a time. It's called single coil activation or single coil driving. So let's run it and we'll see how it is going coil by coil. Okay, we run it only for 8 seconds, so 2 cycles only. It's only building now. Let's see when it starts. So you can see coil by coil. So A, B, C, D, and then A again, B, and C, and D. So one coil at a time for 8 seconds. You can see the pulses. One pulse activated at a time. One coil activated at a time. If you want free running, you can change from 8 seconds. We put it to infinity so that you can write INF instead of 8 seconds so that it is running continuously for infinity. Okay, so once we change that, it's going to run until we stop it ourselves. It will not stop, and you can see one coil is activated at a time. So this part is given for you, how we set the pulses, how we design the driver. So now let's go to part 2 of the experiment. Part 1 is done, and now you know how to set the pulses. Let's go to part 2. We can stop the system, and then we go to part 2 of the experiment. So now we're done with single coil control. We know how to do it. Let's see how to do the full step control in clockwise direction. Now this will be different for full. Let's see how to do it. For full step control, we need to activate two coils at a time. So it is like 1100 011 and then 1001. So two coils activated at a time. So for the first second, we activate A and B, and then B and C, and then C and D, and then D and A. Instead of activating one coil at a time, which is a single coil control, this is now full step control. So two coils activated at a time. Now what you need to do is only to change in pulse generators. So I'll leave this task for you. I will show you the results. You need to do it yourself and send the results how you design it to your doctor, and I'll show you how I did it. This is how I did it. You need, of course, design the pulses yourself. I called it full step clockwise control. So full step clockwise because it is rotating clockwise. Let me run it and show you how the motor is running. Okay, let's wait for building. It's gonna take 1 second for building, and then it's gonna run. And you will observe that two coils are activated at a time. So it's successfully. Now let's see. Two coils activated at a time. We call this one full step control. And you can see the pulses. From pulses, you can understand how to design the pulse generator. So you can cheat from there. But I know that you can do it yourself. Okay. This is about full step control. Let's see the next part. So now we're done with the single coil and with full step clockwise control. Let's see now the full step again clockwise, but with high speed. Let's see how to control the speed of the stepper motor. Of course, the design I'll leave it for you. I'll just explain it for you, and then I'll leave the design of the pulse generator, what you're gonna change, and I'll show you the results. Okay, as we agree. So for controlling the speed, it's still full step clockwise. So the same pulses we are using, activating two coils at a time is the same. But instead of activating one coil for 1 second and then another second, we need a shorter time. We need it to be more faster instead of going second by second by second. Now we need this one to be fast. So think about it. The same design as full step, but we want our system to be fast. Let me show you how I did it. I'll show you the results, and you have to design it yourself. So I call it fast full step clockwise with high speed. I call this block high speed. Let me run it and see how it is, how the motor is moving. Okay, let's wait for 1 minute till it's building now, and then we'll see how the motor is running with high speed, and we'll see also the pulses. Okay, now it's running. Can you see the motor is with high speed? Of course, you will not observe the two coils activated at a time because it is very high speed. I'll show you the pulses. So those are the pulses are for clockwise high speed motor. So design this yourself and send it to your doctor. Okay? This should be, you should have the same result as those pulses. So next part, is the full step again, but counterclockwise. Let's see how to change the direction of a stepper motor. Of course, with low speed, we don't need high speed now. Let's do the same step as part number 2, but in counterclockwise. Okay, let's see how to do it. For controlling the direction, we need the same as what we did in part 2, full step. And each step is for 1 second again. We don't need high speed. But instead of starting from AB, then BC, no, we can start from DA, then CD, then BC, then AB, and so on. So in reverse direction. Okay. Again, I'll show you the result, how I did it. And you can design the pulses yourself and send it to your doctor. Let's see how I did it. I call this one the block. I change, of course, the setting inside for the pulse generator, and I call it full step counterclockwise control. Counterclockwise. Okay, let's wait for the system building, and you'll see that the motor now is gonna run in counterclockwise, and you also will observe the pulses to activate the different coils. Can you see that? The motor is running in counterclockwise, and see the direction of pulses for activating 2 coils at a time is in reverse direction. Okay, this is how I did it, and I believe you can do it easily and send it to your doctor. Let's see now next part. So the last part in this experiment is half step control. Done with single coil, full step clockwise direction, full step with high speed, and full step with counterclockwise direction. Now let's see what is half step and how we can do it. So we explained before the full step, and we said it is activating 2 coils at a time. We can see that we have for 4 coils, we have 4 steps. For half step, we activate 1, then 2. 1 coil, then 2 coil. 1, then 2 coil. So instead of have 4 steps, we should have 8 steps now for a complete cycle. Okay, 8 steps in a complete cycle. Let's see how to do this. So this is how I did it. It's inside there. You have to figure out how to do it yourself. You call it half step. Let me run this one and show you how the motor is running for half step. So remember, it is activating 1 coil, then 2 coil, then 1, then 2, and so on, until we finish the cycle and then repeat it. So 1, 2, 1, 2, and see the movement of the motor and also the pulses. This is how to do half step in forward direction, in clockwise direction. Okay, it's very clear, very easy, and I believe you can do it easily and send it to your doctor. This is about different parts of the experiment. Let me summarize this for you. So what we did is we started with the single coil control. We activate 1 coil at a time for the stepper motor. And then we did full step control in a clockwise. We activate 2 coils at a time in a clockwise direction. And then we control the speed again with a full step. And again with a full step, we control the direction of the stepper motor. And finally, we check the half step. For full step, we saw that we activate 2 coils at a time. For half step, we activate 1 coil, then 2 coils, then 1 coil, then 2 coils until we finish the cycle and then repeat it again. Okay. Let me now show you the final design I did. It's not required from you, of course, just to show you how you can finalize your design in a good way. Okay. This is the final design I did. So we have the motor driver, we have the drive signal, we have the manual switches to switch on and off and to switch for different parts. We have, this is on and off. We have single coil drive, we can choose it, or full step clockwise, full step counterclockwise. You can choose from manual switch, okay, half step and high speed. So this is a simple design that I did. Of course, you can do much better than this one, but just to show you that how to finalize your design to be in a good way. So let me start this one. Now you can see that pulses are zeros because system is off. So it's running, but it is off. Let me handle this. Okay, let's start again. So we can switch on the system, switch on. But before switch on, let's choose one thing. Let's choose, for example, switch single coil. So this is single coil now. Single coil, one coil activated at a time. Let me stop the system and choose full step. Start again. So two coils activated at a time. Two coils. Okay. Let's stop and choose full step counterclockwise. Let me take care of this first. Start. So now it is rotating in counterclockwise. Let's stop again and choose half step. Switch on. So this is half step. 1, 2, 1, 2, 1 coil, then 2 coil activated. We call this one half step control. And finally, let me stop. Finally, we can choose high speed. So this is high speed control. This is the final design, simple design. Yeah, is not required from you, just to show you how to do it. Okay. So thank you very much for joining me in this lab. Very interesting lab, and inshallah, I know that you'll be able to do all this part and send your result to your doctor. And I'll see you in next lab, inshallah. That will be, I think, the DC motor control. Okay. Till then, stay safe. Thank you very much.